Okay, so welcome back. So in the last section, we talk about testing strategy. We talk about unit testing, integration testing, and the system testing. Also, we talk about how to integrate them together. We talk about big bang integration strategy. We talk about top-down, bottom-up, and sandwich integration strategies. So we also discussed white box testing and black box testing. So we talk about all these testing methods and strategies. So how can we actually perform the testing? So in this part, we will discuss the actual testing process. We will talk about test planning, test designing, and test implementation. Okay. So overall processes look like this. So our first step is to determine the test strategy, right? So what is our integration strategy? Do we use white box testing or black box testing? So what are the quality requirements to be tested? The next step is to plan the test. So we should have our test objectives. We should schedule the test, and then we design the test. Actually, this is the actual step to design the test procedures or test cases or test scripts. And then after we design tests, we already have the test cases, then we perform the test. This is also called implementation of the test. We run the test, and we also document the test results. First, test planning. So in the step of test planning, so we want to determine which sources should be used for test cases. These sources are usually about the input of the tests, right? Either we can use like a random sample of the real life cases. For example, if we want to test a new billing system, so we may want to use a sample of shipping bills to test the feature, right? And another way is to use synthetic test cases. As we discussed, we use equivalent classes to actually create some input values. That's a synthetic test cases. These are sources that should be used for test cases. Another thing to plan is who should perform the test. For example, unit tests and integration tests usually performed by developers, and system tests maybe by developers or maybe by an independent testing team. Okay. So, and also we want to plan where should the test be performed. So usually it's performed either on the development side or customer side, or sometimes it can be performed on the cloud, right? So this is about test planning. After test planning, we have a document called the software test plan, or STP. So this is a template for STP. Basically, in this STP, we document the plan details. Okay. So I don't want to go to the details of the plan, so you can check it on the slides later. Okay. Another step is next step is a test design. So basically, we want to produce the test cases. So the products of the test design include the detailed design and procedures for each test. So another thing is a test case database or test case files. So basically, these are the things that that allow other people to follow the procedure or script to run the tests. Okay, so usually the test design results are documented in a software test description or STD file. Okay, so this is a template for a software test software test description file. So it actually includes the detailed description for the test cases. Okay. And last step is to actually run a test. We call it a test implementation. and we want to run a test and record the results and to evaluate whether the results are as expected, right? And we want to correct the errors found in the test results. And after we fix the errors, we want to retest it, where we call regression testing. Let's look at the detailed process of test implementation. So from the test design phase, we have STD, software test description, right? From the STD file, we have the test cases. Then we run the testing based on the STD file. So we run a testing and we generate the results, and we document the results in a file called software test report, which is in short as a STR. So we document the results in STR, and there are two possibilities. One possibility is that the testing indicate acceptable software quality, then we finish the testing. Otherwise, if we find errors or bugs, defects, then we correct such detected errors or bugs. After we've fixed them, we need to run the test again, which we call retesting or regression testing, and we generate another STR, software test report, and we determine whether the quality is acceptable again. If this time it's acceptable, so we end the test. Okay. Sometimes we may run multiple iterations to finish the testing. So this is a process of software testing implementation. Okay. So we use a report, software test report or STR, to report the results of the testing. So basically, this report would document the detailed results, like for each test case. So whether it passed or it failed, and what is the results, and how it compared to the expectation. Okay, so this document, the template shows detailed like elements of the report. Okay. So one way is to run the testing manually, right? So we run other tests. For example, we want to check whether this software is running correctly. We manually run the software and we record the results. But it's sometimes it's a very inefficient, right? And especially when we want to run retesting, run regression testing, we run multiple times. So it's not efficient to run manually. So actually, test automation is very popular for software testing. So we use many automated tools to support automated testing. There are many different types of tools. Like as I said, drivers and stops, something we don't need to write it ourselves, so the tools can help us write it. And there are stress testing and load testing tools, test analysis tools, test report tools, and other tools. There's on the Moodle for this week, under this week's section, there is a supplementary slides. It's from Fabio. It's about test automation. You may take a look about the details of test automation. Okay. Yeah, we talk about testing. So in order to achieve efficient testing and integrate the testing process into our software development process, so continuous integration comes to the stage. So here we talk about the relationship between continuous integration and testing. So why would you continuous integration? So traditionally, the software may be released very slowly, like In Microsoft Windows, you may see it released maybe every month, every like 5 years or 10 years, right? And maybe they will have a patch for every 6 months or so, or 3 months or so. But nowadays, software systems are released much faster. If you check Google, Facebook, Netflix, LinkedIn, Twitter, Salesforce, so they are released multiple times every day. Even like some tools like Netflix, they may be released multiple times every hour. So in order to achieve such a rapid release cycle, we need to test our system faster. We need to integrate all the changes faster, right? So let's look at one example. This example. After we make a code change, right? We make a commit, for example, on GitHub. We need to compile the system, right? To build the system. Then we need to test the system. And if a test passed, then we make this commit to the repository successfully. So all these things are automated in the continuous integration framework. So as soon as you make your code change, you make a commit. So the build, testing, and will be run automatically. So you can achieve the goal of releasing your system multiple times a day or multiple times an hour, right? Like if you make another commit and you build it and you run a test, you may find that the test break, the test failed. Then in this case, you cannot commit this change. You need to fix the issues and do another commit. So this is a continuous integration, is to automate the whole process. So what is exactly continuous integration? What is exact continuous integration? Let's look at the formal definition. Continuous integration is a software development practice where members of a team integrate their work frequently. Usually each person integrates at least daily, leading to multiple integrations per day or even per hour sometimes. Each integration is verified by an automated build, including tests, to detect integration errors as quickly as possible. As soon as you make change, there will be a build and software testing automatically in place. And if there's an issue, it can be reported and can be fixed as quickly as possible. So this is a continuous integration definition. The benefit of a continuous integration is that so we can catch problems early. So as early as the coding decisions are still fresh in our minds. So this is continuous integration. So in addition to continuous integration, we have other things like a continuous deployment and a continuous delivery. So continuous deployment is to deliver the software system to the customer as soon as the code changes are completed. So like it can be delivered to the customers like multiple times a day. Continuous delivery is the continuous delivery of the software to the customer. Continuous deployment is to support the continuous deployment of the software system for example, in a production environment, for example, in the cloud. So they are similar. So one is to the customer, one is to a production environment. So we have a continuous integration, continuous deployment, and continuous delivery. So they are all related to testing because we need to include testing into the cycle of the continuous integration, deployment, and delivery. There are many different tools to support continuous integration. Some tools you need to download and install. For example, Jenkins, Cruise Control, and BuildBot, those tools. So one famous one is Jenkins. There's also some cloud-based. You don't need to install, you just register sometimes a free account and to use it, and you will leverage the computing resource of the cloud. So there are some examples like cloud-based Travel CI and Circle CI. So Travel CI is a popular one. You may take a look. So here I give a small exercise for you to set up a Travel CI for GitHub project. So you can fork this repository to your own GitHub repository, and then you can follow the instructions to set up this Travel CI, and you can try to make a change to the code and to see so whether the Travel CI can do continuous integration for this change. And you can, for example, you can make an error in this change and to see Travel CI can automatically test your software and find this error. Okay. There are other resources for Travel CI. You may take a look. Okay. So this is about Travel CI. So in this assignment, you need to use a continuous integration tool. I think one way to use Travel CI. So continuous integration is also a part of the software quality assurance system. Actually, it's part of the quality infrastructure components. It is the infrastructure to support the changes, support the quality assurance activities, support testing. So next we want to discuss software quality standards. This is a place of the software quality standards in software quality assurance system. Why we need the standards, right? So we need the things to guide our software quality assurance activities, and we need to also sometimes we need to get certification for our software quality assurance, so that our customer can trust the software quality, right, of our company. So standards. So there are many different standards. So we covered the MyCall model. Today we will cover the ISO 25000 series quality standards. So this 25000 series of standards actually are the current standards used by many companies. So let's look at details of this series of standards. So first, this series of standards are proposed by ISO and IEC, International Organization for Standardization, and the International Electrotechnical Commission. So these standards are insured to SQUARE, which is a software product quality requirements and evaluation. So it's a series of standards, not just one standard, it's a set of standards. Let's look at the components of the standards. Basically, these standards include 5 main components. The first component is the 2500N standards. So it describes the standards for software quality management. So the next division is a 2501N standards. It defines the quality models, and other standards define the quality measurement, quality requirements, and quality evaluation. So today we will be focusing on the quality model division, 2501N. It presents a detailed quality model, and it describes guidelines for how to ensure internal software quality, external software quality, and software quality in use. It's actually the practical guidance on the use of the quality model in many companies. Okay, so let's look at the quality model defined in this standard. This is similar to the quality model that is defined by Michael Cole, right? So here, these standards define 5 characteristics related to outcomes of interaction with the system. So these are quality in use. So basically it defines these 5 qualities standards. So one is effectiveness, one is efficiency, and satisfaction, and freedom from risk, and contextual coverage. So these standards basically defines our experience of using a software system. And for each quality factor, there are sub-factors as well. Also, these standards defines the product quality model. So it defines 8 quality factors for a product, including functional sustainability, performance efficiency, compatibility, usability, and reliability, security, maintainability, and portability. So many of them are similar to the ones defined in the microcosm model. And for each of them, there are sub-factors. Okay, so you don't need to remember all of them, just to know that this quality standard defines different factors and sub-factors. And also it defines the examples of the quality requirements for each factor. Okay. So that's it for standard. We don't go to the detail, just to give you an understanding about what are the main components of the current standards 25000 series. So to review today's topics, we discussed the quality plan. We discussed software testing, and we also discussed the quality standards and also continuous integration. So for today, there are a few things to do. The first is assignment TP1. It's available today. I think it will be uploaded today after the class. You can check it on Moodle. This assignment is due on October 5th. It's a group assignment. You should finish it within a group. So basically, for this assignment, you need to prepare a quality plan for subject system, which is OpenMRS. You should choose 2 main features and to make this quality plan, and focusing on functionality, reliability, and maintainability. You should create or reuse test cases according to the quality plan. And you need to consider continuous integration. And also you need to define a new feature for OpenMRS and update your quality plan test. This new feature can be one existing feature of OpenMRS that are not included in your first 2 main features. So we have, we asked you to make some group groups last time. So some of you already send me your group members. Some of you may still looking for team members. I think if you cannot find a team member, or you're looking for a team to join, you can send me an email. So I may randomly group you to some teams. Okay, you can before Wednesday. Just send me an email before Wednesday, so I can make you some random groups.
Sorry, and a student just asked me that what is the software that will be used for the TP1 to do the testing, the configuration? What software they will be using for running their TP1?
You mean the tools, right?
Yeah, which software they will need to use to analyze the OpenMRS? That's what it concerns.
Okay, so the details of the assignments will be covered in the live session on Thursday. But for now, because here we focus on functionality, reliability, and maintainability. I think you can use the software testing tool used by OpenMRS. First, you need to download OpenMRS and check the current testing testing tools. I think probably is JUnit, right? I must
Okay, so they will need to use JUnit for that?
Yeah, I think so, yeah.
Okay, so they will be using it's Java JUnit testing, okay.
And also they need to use continuous integration, which is they can use either anyone, but the recommendation is a Travel CI.
Okay.
Yeah. And for other parts, I think, yeah, that's the tools, the main tools that will be used. Yep. Also, for sure, a Java integrated development environment such as Eclipse or IntelliJ, right? So that is basically to support you to develop the tests, to run the tests, right? And yeah, just check out the OpenMRS the website, especially the development website. They will tell you what is the environment. And also on Thursday, on Thursday in the lab session, Amasa will go through the tools and we'll go through the details of the assignments and what kind of tools that you will be using for the assignment. Okay. And you can check the details of the assignment today on Moodle. Okay. Also, we will have 2 exercises. These are the class exercises, but because now we are doing like a remote teaching, so it's difficult to conduct such exercises interactively. So I want you to, I post this exercise on slides, and I think it may not be on the Moodle version, but I will upload it after this class. Just for this first exercise is to make some quality plans for software system, which is a MintCare, which is an information system for managing records of patients undergoing treatment for mental health problems. So you need to define quality criteria, sub-criteria, metric, and evaluation method for each of the following quality objectives. There are 5 quality objectives. So this is basically what you will do also for your assignment. This is an exercise that I will review it on next Monday. Next Monday. So next class I will review the exercise. Okay. Quality criteria is like a quality factor, like efficiency, right? Sub criteria is a sub factor, like time efficiency. Metric is you define the quantitative measurable metric. Is like response time, like speed, right? And the evaluation method can be testing, what kind of testing, integration testing, system testing, performance testing, or review, right? This is the first exercise. And second exercise is equivalence partitions. So here, there's a consider web page for inputting a student's middle term exam and final exam grades for a course. So you have 4 input fields. So I want you to design the equivalent partitions and also provide your test cases for testing the input. So these are the 2 exercises covering quality plan and also the testing black box, the equivalent partitions. So for this exercise, these are the in-class exercises. So they will be, they should be done during class and in normal times, but nowadays it's I just posted here. You can do it after class, and let's review next class. And also this exercise may be used in a quizzes. I mean, not exactly the same, but something similar, or the final exam. So yeah, I ask you to pay attention to this exercises, okay? And then that's it for today's class. Do you have any question? If no, I think that's it. And please, if you cannot find a team member before a team, if you cannot find a team before Wednesday, please send me an email. So I will make random groups. Okay, I'll make a random groups for those who couldn't find a team. Okay, I think that's it. Thank you, everyone. I'll see you next week. And on Thursday we will have the lab session. So the lab session will be held by Martha. Okay. So you can check there's a Zoom link on Moodle for the lab sessions. Okay. Bye bye. Thank you. And I will post the videos on YouTube as last time. Okay.
Thank you.
Bye bye. Thank you.
Thank you.
Bye bye. Thank you.